So in order to understand how to explain transformations of equations or functions, you need to first understand the different types of transformations that exist. So there are 4 different types of transformations that we're going to be dealing with throughout this. First of which I'm representing using A. You might see this using a different letter, but A is generally the choice that I like to use. So A is the one that's being multiplied not directly to x, so it's being multiplied by a larger portion of the equation than just x. You'll see it usually in front of the operator or on top of the operator if we're talking about a rational function, and it represents vertical stretch and shrink. Now, notice it is being multiplied directly by the equation. B is a little bit closer to x. B will always be multiplied directly by the x. This will be horizontal stretch and shrink. So if we're thinking about the difference here between these 2 different types of stretch or shrink, if I have a graph here, so let's make it an absolute value, because why not? A would be like pulling my graph up or down. So this would be an A. B would be pulling our graph side to side. So while you could make the same types of transformations using both letters, so I could pull a graph vertically or I could pull it horizontally to get to a certain type of stretch or shrink, it's important to recognize where they fall in the equation because it means that you're doing your stretching at different times. Next up would be our h value. So h is inside of the operator, and it's being added or subtracted directly from our bx pair here. This is going to be your horizontal translation. Meaning h will move your graph side to side. So it will pick up this absolute value graph and shift it to the left or to the right. So a lot of my students talk about this as being opposite. And then they just kind of assume that there's some sort of magic going on here, but there's not. The interesting piece about h is the fact that it's being subtracted. Notice k is not, k is being added. Since we're subtracting our h value, it automatically makes it appear as though it's the negative version of whatever you are actually moving. So it shows up when you're looking at your equation as though it is opposite, but it's not really opposite. Finally, we have our k value. Now k is our vertical translation. So k takes our graph and moves it up or down. So each of these 4 different types of transformations affect your graph in a certain way, and it's going to be important for you to recognize where they are in order to know what you're doing. So let's make up an example. So something I like to do when we first start talking about transformations of functions is go through and recognize which types of transformations do I have. I like to recognize them by their letter because that just makes life a little bit easier for me. So in this function, so notice here's our operator here in the middle, the log. So this part is our operator. So when we're thinking about what I was talking about here, these squiggly lines were the operator, meaning anything in front here being multiplied by our operator would be an A, anything inside of it would be a B or an H. So out front here, multiplied by our logarithm, I see a 2. That means this 2 must be the a value, since it's being multiplied by the entire logarithm. Inside my logarithm, I don't see anything being multiplied by x, because right here is where b would normally be. I see an h value, because it's being added or subtracted from our h value, or from our x, and finally a k value. So now that I've figured out what's where, we can go through and start to talk about what's going on. Now, it usually makes the most sense to start from x and kind of work your way out following your order of operations. So starting with my x, the first thing that we're doing is moving our left or right, because normally we would be dealing with b, but there's nothing there. So my graph is being moved to the right 4. Remember when we talked about h, we said it shows up looking opposite. So when I look at my equation here, it looks like it says -4. But remember, the negative sign here, the subtraction sign in the middle, was standard with any type of equation we're dealing with. So the h is just the 4, not the negative. So our graph is moving right, or positively, 4. Working my way out, following my order of operations, the next thing that would happen would be this 2. So then it's being vertically stretched by 2. And finally, the last thing I would do would be moving the graph up 1. So that would be an explanation of what's happening. Now, in case you're confused on how I knew right or left, think about it on a graph. So moving this direction would be positive, and moving this direction would also be positive. Going either of these two directions would be negative. So if I have a positive 4, that would mean I'm moving to the right 4. And since I had a positive 1, I was going up 1. So that's how I knew positive, positive, negative, negative. Let's try another example. Okay, so the first thing I like to do is go through and recognize my A, B, H, and K and make sure I know where they are. So first of all, I see my operator is the square going on here, meaning I am looking at a quadratic. So that's my operator. Okay, so that means everything else going on other than the x should be an A, B, H, or K value. So I see a number out front being multiplied by the entire thing, or the entire operator here. So that would be an A. I see a number being multiplied by the x only. That would have to be a B. I see a number being added or subtracted from the x. That has to be an H. And I see a number being added or subtracted from the operator, which must be a K. Now, when I say go in order of operations, think about if you were to plug in a number for x. What would you have to do to start to simplify this? Like, the first thing I would do if I were to plug in a number for x is I would multiply by 6. So I'm going to talk about that piece first. So I see a horizontal stretch, or shrink, depending on how you want to think about it. In fact, in this one we'll call it a shrink because it's getting skinnier. Our h would be the next thing we would do, so that would mean we would move right, because again, the negative sign is part of the equation, 1. The next thing I would do would be multiply by 1/2, so this would be a vertical shrink by 1/2. And the last thing I would do would be to move my graph up 3. So you might be kind of hung up on how I decided that this was going to be a shrink here. The way that I was always taught to think about it was you're making this happen this many times as fast. So this is happening 6 times faster than normal, which means it's getting 6 times skinnier. Where out here, it's getting half as tall. So how much faster or slower this is happening, and this is how much taller or shorter. So when a number is larger than 1 for our b value, it would be happening faster, meaning it's getting skinnier or shrinking. One last one before I unleash you to try this on your own. Okay. First thing we like to do is recognize our operator. So in this case, the operator would be the cube root. That just helps me figure out where my a, b, h, and k are again. So that's why I go through and do that every time. Out front, this is unique. I have a -3 for my a value. Inside, multiplied by b, or multiplied by x, we have our b. Here we have our h inside, being added or subtracted from the x. And added or subtracted from the whole operator would be k. As a side note, you could see these things in different orders, so think about how I'm referencing them. So a is multiplied by the whole operator, b is multiplied only by x. H is added or subtracted only from x, where k is added or subtracted from the whole operator. So if we start to go through and explain what's going on here, very first thing we would deal with is if I were to plug in a number for x, how would I start to simplify? I would normally talk about b, but I don't have one. So this graph is being moved left 6. Now, I know that because it's normally x minus h. So in order to get a +6 here, that would need to be x minus -6, meaning moving left on a graph 6. That's how I knew to move left instead of right. Next up, we would need to flip our graph over the x-axis. You're probably wondering, how in the heck did you know that? Whenever you see a negative out front, that will be a flip over the x-axis, because what's happening is our graph is going from normally facing as it would, and it's flipping over and going the opposite direction. Then it's got a vertical stretch by 3. And finally, it's moving down 5. All right, I lied. One more example, because I have one last thing I want to point out. Okay, so this one looks a little bit weird, but again, think about our operator. So this would be my operator here in the middle. This would be a rational function. Ooh, operation, that's not what I wanted to spell. Operator. Which means that this must be my a value because I'm multiplying up there, or dividing, I guess. This must be my b value because it's being multiplied directly by the x value. H would normally go right here where I see nothing. because that's where I would add or subtract directly from x. And then this must be my k value because it's being added or subtracted from the entire operator. Okay, so going through our process. First thing I would do is I would multiply by my -2. So I need to talk about that first. Now before we said a negative on the a value was a flip over the x-axis. If you see it in the b value, it's a flip over the y-axis. Then we have a horizontal shrink because it's happening twice as fast. There's no left or right. Then we have a vertical stretch because our graph is getting 8 times taller than normal. And then our graph has been moved up 6. So the big pieces to remember here is as you're going through and figuring out what goes where and when to do what, just remember to keep track of where your operator is and where A, B, H, and K are. If you're looking for a basic order of how you would go through and explain them, that's the order in general that you should be talking about them.